In addition to representing sequences with an explicit formula, we can also represent them with what's called a recursive formula. And so hopefully you guys remember from last week that a recursive formula requires us to know about the previous term in order to calculate the current term. And in general, when we go ahead and write a recursive formula for an arithmetic sequence, we're going to use this equation here. It says in order to find our current term, we're going to take our last term, write our previous term here, and we're going to add to that our common difference. Okay, so we're going to go ahead and look at a couple examples on how to tackle this. So example 6, we're asked to write the recursive formula for the sequence 4, 12, 20, 28, 36. So the first thing that's going to be important to do, really important for this idea of recursion and recursive formulas, is we need to identify a sub 1. Okay, it's super important in dealing with recursive formulas to identify your first term, because we need to know where this pattern starts. Okay, so just like before, unless indicated otherwise, a sub 1 is just going to be that first term listed. So here we see that a sub 1 is equal to 4. Again, just like before, we're going to also need to identify or find our common difference. And in looking at our sequence 4, 12, 20, 28, 36, I see that common difference is 8, right? 4 plus 8 gives me 12. 12 plus 8 gives me 20. 20 plus 8 gives me the 28, and 28 plus 8 gives me 36. So I'm told that D, or I guess I'm given in this sequence that D is equal to 8. Okay, and then the last step of this is really just putting this all together. Step 3, plug in our values to our a sub n equals a sub n minus 1 and then plus d, and we also must state our a sub 1. Okay, so a sub 1, that statement of your a sub 1 is going to be part of your final answer. Okay, so our final answer here will be our current term, a sub n, is found by taking our previous term, a sub n minus 1, and then adding 8. And that is starting at a sub 1 equals 4. Okay, so you'll notice, just like in the explicit formula, our common difference and our a sub 1 are both used to communicate the formula, but they're used a little bit differently, right? You have your common difference here being added to every previous term, and then our first term is kind of stated as a secondary fact, but very necessary to help us understand where this pattern begins. Okay, let's go ahead and conclude this video with example 7. Okay, we're going to follow the same kind of recipe here. Step 1, we need to identify a sub 1. So what is a sub 1 equal? We'll just go ahead and do that from inspection of our sequence, right? We're given a sequence of terms, and we aren't led to believe that a sub 1 would be anything other than that very first term listed. So a sub 1 equals 33. Our second step would be to find our common difference. Okay, so find that value of D. In listing out, sometimes I think it's helpful actually to write out the sequence just to help your brain kind of pick up on the pattern, but some of you might not need to do that, and that's totally fine. But in either listing out this sequence or studying this sequence, I can see that my common difference is negative 11. If I subtract negative 11 from each of the previous terms, I'm landing at the next term. Okay, so finally, we just need to fill in the pieces. So kind of plug in to that form a sub n equals a sub n minus 1 plus our common difference, making sure that we're stating our first term. Right, we want to make sure we identify where this pattern starts. Okay, so our final answer will be that our recursive definition is a sub n equals a sub n minus 1. And then outside of the subscript, right, this is a whole value integer that's being added, or I'm sorry, subtracted from every single term. We have that minus 11. And again, we want to say that this is starting with a sub 1 equals 33. So that recursive definition as well as the statement of a sub 1 is our final answer. It wouldn't be considered a complete answer if we didn't indicate where this started. Okay, so that's super important because if we start subtracting 11 from a different number than 33, we're going to generate a completely different sequence. Okay, go ahead and try problems 8 and 9. They ask you to write the recursive equations for 2 arithmetic sequences. So use this video as well as the guided notes posted on Google Classroom to see if you can do that.